Hello everybody, we are starting chapter 9, and in chapter 9 we're really getting into some heavy duty statistics, which this is pretty much what we've been building up to the whole semester up until now, because in section 9.1 we're going to be estimating here a parameter for a population based on a sample, and we're going to be doing things like building confidence intervals and all of that kind of stuff. But in the case of 9.1, we are talking specifically about proportions. And a proportion is just talking about a percentage of a population that does something. So it could be talking about, well, we will see for sure in some examples, but a proportion could just be, what is the proportion of the population that prefers chocolate ice cream versus all the other flavors and stuff like that. Now, we will have some more notations, and sadly we don't get any more Greek letters for this one. The notation we're going to use for a proportion, we will see the familiar hat situation with the sample. It will go p hat, and then for the population it would just be called p, just regular p. And we will find p hat by just dividing x, which is the number of successes, so that's what we're looking for. The number of people in the population that we're looking for, or else, it could be number of successes as far as if we're doing an experiment or something like that. And then little n, this will be the number of trials, but of course, number of trials is always just the same, or the little n, it would just be the sample size. And so we will use this term, it's called point estimate. And what the point estimate is, in this case, the point estimate for proportion, and proportion here is p, of course, for the population, but the point estimate that we're going to use is going to be the one p hat. When we're estimating a proportion for a population, we're just going to use the proportion that we get from a sample, because hopefully, of course, the sample should be representative of the population. It should be a random sample. It should be such a nice sample that we can use that as our point estimate. And basically the point estimate is going to be in the middle of our confidence interval. It will be exactly in the middle of it. But a point estimate in general, it's just what it sounds like. It's an estimate of a parameter. It's a statistic that estimates a parameter. And so, like I said, we're talking about the proportion of a population. In this case, we'll estimate it by using the proportion from the sample. And a confidence interval is an interval of values that the population we're hoping, here's maybe kind of a number line, and we will come up with some interval on the number line, and we will say hopefully the actual parameter is somewhere in here. So our point estimate will be in the middle. We will have a margin of error on either side, and we will say that hopefully the parameter should lie inside of here, is here, we hope. We hope, or else we guess. We hope. If you can read it, you hear what I'm saying. That's what I mean to right there. And the way we're going to just build a confidence interval is we will put the point estimate in the middle, which is going to be, in the case of proportions, it will be p hat there. And then we will find this left bound by subtracting the margin of error, and then we will find this right bound by adding the margin of error to that one. And we will find out a little bit later how to find out how much the margin of error is, but naturally the calculator is going to take care of that for us. We will see the formula anyways, but this is just going to be some more calculator buttons that we can rely on for this one. And whenever we're doing the confidence intervals, we will use this kind of a terminology, level of confidence, and that will be basically the name of the confidence interval. It can be a 95% confidence interval or 90% confidence interval or whatever. And we will see sometimes the level of confidence being related to this one, the alpha value, because the probability that we're talking about, and we will see a nice picture of it in a little bit, but this, and especially tying it into chapter 8, where remember we were talking about the distribution of a sample, the distribution of the sample mean and stuff like that. It's going to be possible, of course, to get some lucky samples where your point estimate is just way off because, we're judging our confidence interval based on the point estimate. But if we get some type of a crazy sample where the point estimate is just way off, then we will get a confidence interval that does not contain the true parameter. And we'll see a picture of it in a second. I don't want to get too far ahead of myself. But in general here, we're still, we're talking about the alpha value. And it's just another way of representing what the confidence level is. So this is the level of confidence here. I will write level of confidence. And if it's a 90% confidence interval, then the alpha value is 0.1. Because, of course, 1 minus 0.1 is going to be 0.9. And then if you go 0.9 times 100%, you will get 90%. And then the same thing like 95%, it should be alpha level of 0.05. This will be a very common one because, of course, this has to do with the idea of significance or something being unusual is if it happens less than 5% of the time. And then alpha value, this would be if you want to be very confident. 0.01, this will relate to 99% confidence. And so naturally, if we want to have a higher level of confidence, we should have a higher margin of error because you want this interval to be bigger. If the interval is bigger, it's like a wider interval, it would be more likely to contain the parameter. Of course, you just make it wider, then you have a better shot of the parameter being in there. And if you make it even wider than that, then it's more likely the parameter's inside of there. So we will also have that as the sample increases, the margin of error will decrease. So if you get a larger sample, then the margin of error will be smaller, and that will be based, you'll see the formula for margin of error later. It's based on the sample size somewhat. And then we also have that the larger the spread in the population, so that's basically, if you look at some sort of a distribution of the population, if the values are spread out more, so we're thinking, higher standard deviation, something like that, then the interval should be wider as well. But anyways, we will pick up right here.